Never happened? Not a day in your life, right? Too many nuggets at the Chick-fil-A, a couple too many donut holes, too much chips and queso, okay? Am I speaking your language? Too much. And then you can't finish your dinner because you ate all the chips and queso? Yeah. Okay. So we're going to work through this. We have this function here. We have this function here that represents when he's getting happy and then when he's quickly becomes no longer happy. Okay, so we're going to go ahead and remind ourselves what the quadratic formula is. Opposite b plus or minus the square root, b squared minus 4ac, all over 2a. Right? So we've got the quadratic formula there. Okay. One of the things we should do first is label our graph. Okay. So we have our x and our y. Our x is going to represent the number of cheeseburgers. Which means our y is going to represent our happiness level. Okay. So we're going to go by 2 cheeseburger increments, but I'm only going to show the evens because otherwise it's going to get really crowded. And then we're going to rate our happiness out of 5s, but I'm going to make that be every 2 lines. So like this would be 2.5, this would be 5, 7.5, 10, but I'm only going to show the 5 increments. So now we're going to use the quadratic formula over here on this side to figure out what our x-intercepts are. And then over here we'll use this space to find out the vertex values. So for the quadratic formula, opposite of b is going to be -6 plus or minus the square root of 6 squared minus 4 times -1 times 16 divided by 2 times 6. Excuse me, 2 times -1. So now I have -6 plus or minus the square root of 36 plus 64 divided by -2. Now sometimes the answers we get for our x-intercepts don't make sense given the scenario, right? So you can't eat -2 cheeseburgers, right? So that's not going to be part of our graph, but you could eat 8 cheeseburgers. So our ordered pairs are -2, 0.
Wait, did you get 8? Did you do 10 minus 2?
Nope, I did -6 minus 10 is -16. Divided by -2 is 8.
Oh, my bad.
It's okay. So this one obviously doesn't make sense in the context of the scenario. You're not going to, there's no way to demonstrate eating -2 cheeseburgers. But I can eat 8. So my first x-intercept is going to be right here at 8, 0. If this was 4 quadrants, I could demonstrate where -2 would be, but for this scenario, we don't need that, right? So now I know where the parabola is going to go through the x-axis. Now I just need to find out the vertex, right? So we need our x value of the vertex. So you should get 3. So that tells me how many cheeseburgers he's going to have when he's at the happiest. Because that's the peak of his cheeseburger happiness level. Now we have to figure out what is that number on his happiness level. Right? So now we need to find the y value of the vertex. So remember, we have this negative outside of the 3 squared. So you're going to get 3 squared, and then you have to keep that answer negative. Right? It's not -3 squared, it's the opposite of 3 squared. That's what that stands for right there. So our vertex is going to be 325. Now here's where it gets a little abstract. I mean, what is to say his happiness level before he even had a single cheeseburger? So this is where you're just going to estimate where the parabola would continue to go, like mirror it on the left side. Okay, now, if we had the -2 over here, we could actually draw it perfectly through, but we don't. So I'm going to connect this down here to this point, and then I'm going to estimate about where it would continue down here on this point. And I didn't even do a great job of that. Right?
How did you get that perfect line?
It's not perfect. And also I've been doing, it should be better based on how long I've been doing this. Let's be real.
Dude,
Okay, just do the best you can. Just do the best you can. So here's the thing. We will work with our binders tomorrow. I just want to make sure your table of contents, I have an up-to-date table of contents that you have to look at. So when you're going through your binder, I don't have that today. We're not done yet. Don't put your things away. I just don't want you guys thinking I forgot about the binder situation. Okay, if your friend wants to be as happy as possible, how many cheeseburgers should he eat? How do you know? How many? How do you know? 3. How do we know? Yeah. He should eat 3 because it's the highest happiness level. Oops, sorry. What does the y-intercept of the graph represent? Yeah, happiness before eating any cheeseburgers. I wish there was a way to measure like your happiness level, because like mine drastically increases after I have Starbucks in the morning. But I only have one.
Do you have it every morning?
More than I should, yes.
What?
Yep. But now I have to buy a new car, so probably Starbucks is going to be the thing to go. That's what's going to happen. Got to cut things out when you need a budget. How many cheeseburgers can your friend eat before he becomes unhappy?
3.
So if this is his happiness level is dropping, but how many until he's officially unhappy?
Huh?
More than 8, 8 or more, right? Because now he's at 0. 8 or more. Personally, I think that's not a wise choice, but.
Wait, is it asking like how many will need to eat to be unhappy?
So unhappy would be here at the. So this he's still happy down here. Not until he gets to 0 would he be considered unhappy. Okay. What if he ate 10 cheeseburgers?
He'd be super unhappy.
Well, let's put 10 into the formula. So y equals opposite of 10 squared plus 6 times 10 plus 16. So we're going to find out exactly how unhappy he is.
Is that plus 16?
Yeah.
Okay.
Yep. Super unhappy. Negative 24 happy scale means you are not happy.
Wait, is behind that 10 in the parentheses, is that a plus or minus?
It's a plus. It's just the formula up at the top. It's a plus.
Oh, it's just a...
It's just the equation up at the top. I know the lighting is like terrible up here.
Wouldn't it be minus? Oh, wait, it's plus. My bad.
Okay, we will continue this fun tomorrow.